determine if it is safe to change a light bulb, you need several pieces of information. Firstly, what is the voltage and wattage of the light bulb? Secondly, what type of light bulb is it, such as fluorescent, compact fluorescent, incandescent, or high-intensity discharge, also known as HID? Thirdly, is the location of the light in or near a pool or bathtub? Fourthly, what is the size of the branch circuit that is feeding the light bulb? Fifthly, is the circuit between the light bulb and the panel properly wired and grounded? Sixthly, how many other light bulbs are on the circuit? Let's delve into each of these aspects to understand their significance in ensuring a safe light bulb replacement. Firstly, the voltage and wattage of the light bulb are crucial parameters. Voltage, measured in volts, represents the electrical potential difference that drives the current through the bulb. Common voltage ratings for light bulbs in residential settings are 120 volts and 240 volts. Wattage, measured in watts, indicates the rate at which the bulb consumes electrical energy. Light bulbs are available in various wattages, ranging from a few watts for small decorative bulbs to several hundred watts for high-intensity lighting. It's essential to use a light bulb with the correct voltage rating for the electrical system. Using a bulb with a lower voltage rating than the supply voltage can cause it to burn out quickly, while using a bulb with a higher voltage rating may result in dim light or no light at all. The wattage of the bulb should also be within the limits of the light fixture and the circuit to prevent overheating and potential fire hazards. Secondly, the type of light bulb significantly impacts its energy consumption, light output, and operating characteristics. Incandescent bulbs are the oldest type of electric light source, producing light by heating a filament until it glows. They are relatively inexpensive but inefficient, converting only a small percentage of electrical energy into light. Fluorescent bulbs, including compact fluorescent lamps, also known as CFL, generate light by passing an electric current through a gas-filled tube. They are more energy efficient than incandescent bulbs, producing more light per watt of electricity consumed. However, they contain a small amount of mercury, which requires proper disposal. High-intensity discharge bulbs, or HID, are used in applications requiring high light output, such as street lighting and stadium lighting. They produce light by creating an electric arc through a gas mixture. HID bulbs are very efficient but require a ballast to regulate the current. Each type of light bulb has its own characteristics and safety considerations. For example, some halogen bulbs can get extremely hot and pose a fire risk if they come into contact with flammable materials. CFL should be handled with care to avoid breaking them and releasing mercury vapor. Thirdly, the location of the light fixture is a critical factor in determining the safety requirements. If the light fixture is located in or near a pool or bathtub, it must comply with stringent safety regulations to prevent electric shock hazards. These regulations typically require the use of ground fault circuit interrupters, also known as GFCIs, to protect against electrical faults. GFCIs are designed to detect small imbalances in the current flowing through a circuit and quickly shut off the power to prevent electric shock. Light fixtures in wet locations must also be rated for wet locations and properly sealed to prevent water from entering the fixture. Additionally, the light fixture should be installed at a safe distance from the water to minimize the risk of contact. The National Electrical Code, or NEC, provides detailed requirements for electrical installations in and around pools and bathtubs. Fourthly, the size of the branch circuit feeding the light bulb is crucial for ensuring that the circuit can handle the electrical load. The branch circuit is the wiring that extends from the circuit breaker and the electrical panel to the light fixture. The size of the branch circuit is determined by the gauge of the wire, which is measured in American wire gauge, also known as AWG. The larger the AWG number, the smaller the wire diameter, and the lower the current carrying capacity. Common branch circuit sizes for lighting circuits are 15 amp circuits and 20 amp circuits. A 15 amp circuit is typically wired with 14 AWG wire, while a 20 amp circuit is typically wired with 12 AWG wire. It is essential to ensure that the total electrical load in the circuit does not exceed the circuit's capacity. Overloading a circuit can cause the circuit breaker to trip or, in severe cases, lead to overheating and fire. To determine the total load on a circuit, add up the wattage of all the lights and appliances connected to the circuit. Divide the total wattage by the voltage to calculate the current in amps. The current should be less than the circuit breaker rating. Fifthly, the condition of the wiring and grounding is critical for electrical safety. The wiring should be in good condition, with no signs of damage or deterioration. Damaged wiring can cause short circuits, which can lead to fires. The grounding system provides a path for fault current to flow back to the electrical panel, tripping the circuit breaker and preventing electric shock. The grounding system should be properly installed and connected to all metal parts of the electrical system, including light fixtures, metal boxes, and appliances. The ground wire is typically a bare copper wire or a green insulated wire. It is essential to test the grounding system periodically to ensure that it is working properly. This can be done with a multimeter or a ground fault tester. Sixthly, the number of other light bulbs and appliances in the circuit is relevant for assessing the overall load on the circuit. If there are many other lights and appliances connected to the same circuit, adding another light bulb may overload the circuit. As mentioned previously, overloading a circuit can cause the circuit breaker to trip or lead to overheating and fire. To determine if a circuit is overloaded, add up the wattage of all the lights and appliances connected to the circuit and divide by the voltage. If the resulting current exceeds the circuit breaker rating, the circuit is overloaded. In this case, you may need to reduce the load in the circuit by removing some lights or appliances or by installing a new circuit. In summary, to determine whether it is safe to change a light bulb, consider the following factors. Firstly, voltage and wattage of the light bulb. Secondly, type of light bulb: fluorescent, compact fluorescent, incandescent, or head. Thirdly, location of the light in or near a pool or bathtub. Fourthly, size of the branch circuit feeding the light bulb. Fifthly, whether the circuit between the light bulb and the panel is properly wired and grounded. Sixthly, the number of other light bulbs on the circuit. If you are not sure about any of this information, it is best to consult with a qualified electrician.